We are ready now to start talking about the actual graphing of functions of two variables. First, a definition. If f is a function of two variables with domain D, then the graph of f is the set of all xyz ordered triples such that z equals f of xy. And as I said earlier, the graph of a function of two variables will be a three-dimensional surface, just as the graph of a function of one variable is a two-dimensional curve. So let's see an example. Let's sketch the graph of the function f of xy equals 10 minus 5x minus 2y. In other words, we're graphing xyz points where the z is computed by going 10 minus 5x minus 2y. Now, there's something kind of special about this function, and that is that this is a linear function. So it's analogous to in a function of one variable where you have f equals mx plus b. So constant times x plus a constant. And the graph is a line, which is why we call the function linear. What we have here is a function of two variables that's of the form I've got a constant, and let me actually put these in a slightly different order. I've got a constant times x, a constant times y, and another constant. Notice there's no squaring or cubing on the variables. There's no square rooting of the variables. There's nothing in there like exponentials or logarithms or tangents or anything like that. It's just constant times variable, plus perhaps a constant term. And the graph of this, well, it's not a line because it's in 3D. It's a surface, but it's a very flat surface. What do we call a flat surface? A surface with no curve? That's a plane. So when you see a function of this form, you know the graph is going to be a plane. And knowing the shape is very helpful because it means you don't have to plot 2 bazillion points to figure out what the shape is. We've actually already seen planes in 3D a little bit from when we were working in 8.1. If you look at example 5 in the textbook, we were introduced to the graph of z equals 5, which is a horizontal plane because this is describing the surface where all the points are exactly 5 units above the xy plane. And notice this is a linear equation. You could think of this as z equals 5 plus 0x plus 0y. In that same example, we also looked at we're introduced to a vertical plane. The equation of that plane was y equals 5. So that equation y equals 5 is saying graph all the points where the y coordinate is 5, x and y can be anything. So they're all going to line up with 5 on the y-axis. And then also in 8.1, homework problem number 5. You were asked to graph x plus y equals 2. And that was also a vertical plane. I know things are vertical when the z doesn't show up, because if the z isn't in the formula, that means that z can be anything, and if you can go up and down from your points as far as you want, then you've got a vertical surface. And this plane goes up and down from the line x plus y equals 2, which is that line, and then since z can be anything, it's going to go up and down vertically from there. And this is also a linear equation because the x and y don't have any exponents, they're not inside a log or a square root or whatever.